Okay, this is part 2 on our tutorial of projective measurements and operations. Let's look at a specific example. So suppose we have a qubit in the following state. Psi is equal to 1 on root 3, 0, plus root 2 on 3, 1. Now, using the projection operators defined in the following way, so let's say we have P naught defined as the outer product of 0 with itself, okay, and P1 is equal to outer product of 1 with itself. Okay, so this is an example. We have all these definitions here. The question is, indicate the probability of finding 0 and the probability of finding 1 when a measurement is made. So the measurement is made using these projection operators. Now let's say we didn't know anything about anything here, okay? So if I ask you the probability of it collapsing to 0, simply look at the coefficient out the front and take the square of it, the modulus squared. So the square of this is just 1 on 3, so that's the answer. Let's go to 1, the probability of it collapsing to 1, look at the coefficient out the front and square it, 2/3. Okay, so straight away we know the answer. The answer of probability of it collapsing to the ket 0, let's denote it that way, is equal to 1/3. And the probability of it collapsing to ket 1, defined like that, is equal to 2/3. So this is the answer. Now we're going to get much more difficult examples, so let's go through it explicitly and see if we can understand where it came from. Okay, so we want to calculate P naught. Okay, so we want to calculate P naught. Now P naught, the probability of finding ket 0, is defined as in this way. We've done it in a previous tutorial on this. Okay, so simply put, it's this operator here sandwiched between the bra psi and the ket psi. Okay, and similarly, probability of it collapsing to 1 is pretty much the same thing, except in the middle now it's going to be sandwiched with the operator that we're concerned with, projection operator P1. Okay. Now, let's actually look at this further. So if we expand this explicitly, we're going to see the actual definition that we had from the last lecture. Okay, so let's put in now these particular values into these equations. Okay, so psi P0 is the outer product of 0 and psi. Same down here, except now we have 1, outer product of 1, psi. Now remember, this should look familiar. From the previous tutorial, we said that this is just like the modulus squared of something. Okay? And in fact, it's the modulus squared of this. So the projection of 0 or 1 onto the ket psi modulus squared. Okay? So these two things are what we want to actually explicitly calculate. Okay? This is a definition of a projective measurement onto a qubit. Now let's look at this in more detail. Okay, so let's first calculate. We want to calculate this. Okay, so let's calculate this part of it first. Okay, so we have P naught acting on psi is equal to P naught is just put brackets around this because we're going to multiply it by something else in a second. Is that multiplied by psi? Now psi is given up the top. 1 on root 3, ket 0 plus square root of 2/3, 1. Okay. Now this might look a little complicated here, so let's just look at what we need to do. What happens here is this thing here, this bra of this projector, is essentially the thing that we're concerned about. It's going to multiply itself by this, or known as act on 0. And this 0 bra is going to act on ket 1. Okay, we're going to leave this guy here just untouched. Okay, and remember, when this acts on this, the coefficients come out the front. Okay, so let's do that. Now we've got this ket 0, remember, that stays there by itself. So let's put brackets around everything else so we don't get confused. 1 on root 3, 0, 0. Remember, this acts on this and the coefficient does not play a part, so it comes out, plus square root of 2/3 acting on the inner product of 0 and 1. Now we know these are basis states, and we've discussed this a few times now. When it's orthogonal, this term vanishes, 0. When it's itself, inner product with itself, it's equal to 1, or what we call unity. So now we can write this whole thing, getting rid of the 0 term now. We simply have 1 on root 3 ket 0 is our final answer. So this is the state it gets turned into, okay, after projecting onto using this operator. Okay, now we said this a few times now. What we want to do now is act, so we've actually calculated this part here. Now what we want to do is act psi, bra psi, onto this part, which is equal to that. Okay, so let's scroll down and calculate that. So we want the probability again of 0 is equal to psi acting on what we just calculated, 1 on root 3, 0, this, and let's define this again. So it was 1 on root 3, 0, plus the square root of 2/3, 1, and let's put this guy back in here. Square root, 1 on root 3 ket 0. Okay. Oops, sorry. So let's see what I've done. I've just done the ket here. We actually want the bra. Now remember, the bra is just, so let's get rid of this. We've got to be careful here. So we actually keep these coefficients. Bras, kets become bras, and bras become kets. So this should be 0 like that, and this should be 1. Okay, now we do the same thing as before. 0 now acts on both 1 and 0, but remember, when 0 gets multiplied by 1, it's going to be 0. So effectively, we only have, final answer, 1 on root 3 squared, because we have this coefficient 2, acting on 0, 0. This is 1, I've said that a few times now, and the final answer is 1/3. Now we knew that was the answer, so we've gone a long way to get that, but as we'll see in forthcoming tutorials, things will get very, very complicated, so you just can't look at it and say that's what the answer. So now we have a recipe for doing that. For an exercise for you, I'll leave calculating the probability of 1. Okay. Now we know the answer for that already, it's 2/3, but go through the exact sort of techniques that I introduced in this example to calculate that.